Hello and welcome to OpenGL Screencast number 12. We'll be talking about lighting and material today, mostly talking about setup and doing some normals. I did a little bit of rearranging again of the code. You'll have to take a look at it on your own because we don't have enough time to cover it all. But I have a bunch of globals that are already set up, and these are going to be some screencast specific variables, so I can reuse a lot of code. And I have a redisplay all function here, which we'll take a look at briefly too. So that's the main. If we go and look at the interactions here, I'll just show this real quick. I added several interactions for the lighting. We'll have a toggling light on off, moving the light, the elevation, the distance from the center, ambient, diffuse, specular emission levels, and shininess. And those are all things used by lighting. I also got rid of the orthogonal, so we're only doing perspective mode here. I also added a shifter here, so glutGetModifiers allows us to see if the shift key is activated. So this allows us to check if the shift key is activated and move the screen right or left, or rotate it if we're holding shift. So that allows us to do a little more with our movement around. Looking else, what we have here. If we look at common, I added a bunch of just defaults that will be used throughout. That just makes it a little easier to keep track of things, as well as initializing things. So for lighting, degrees, etc. So if we look at the initialization now, we have a consistent setting all of these parameters, so we don't have to set them multiple times. We look at comment or screencasts, excuse me, we have all our externs here, all the same. I just added the lighting ones. If we look here, I added a few more for the perspective. The eye center position for X, Y, and Z. That will be used when we look in the display here, and we take a look at this display eye. This is for the rotation I was telling you about. So this is the eye centers X, Y, Z, and then we rotate or move right or left on the X and Z axes. So that's that. And we have the shapes has been modified. We added in the cubes we added normals. So if you don't remember what a normal is from linear algebra days, if you have 3 points, you have a plane on those 3 points. A normal is something that is perpendicular to that plane. So you have to calculate your normals when you're doing any kind of lighting within OpenGL. So for example, this top of the cube, even though I have 4 points here, they're all in the same plane. They're not 2 different planes. So I'm able to say that on the front here, this is the normal 0, 0, 1. So this is coming toward, coming towards the user when the square is facing towards them. Same thing, normal is going backwards, so it's a negative, right and left. Also added the sphere from before. The big difference is it's got some material stuff in here, which it really doesn't deal with in this particular episode, so we won't go into these in detail. It calls this vertex thing, which also has its own normals, which is the same as the vector when you have a sphere from the origin. So that makes calculating normals for a sphere actually pretty easy. So kill that, and we have draw. So here we have our axes. We want to disable lighting within the axes, so we added that. And if the lighting is on, we also go ahead and enable it back. We have this draw light function, which we'll come back to. Draw parameters, we added a bunch of stuff on here for the light information that you can take a look at. The draw scene, now we break into the screencast ID so I can reuse code. And then if you look in each of these, we have, this is just screencast 11, and here's screencast 12. Here's a note when we draw the light, and then we're going to draw a cube. Anything with lighting should be drawn after the light. So let's go ahead and make this real quick. And then after we do so, we can take a look and see what's going on. So here's that rotation thing I was telling you about. We can rotate it now as well as going back and forth. So that makes us so we can see a little bit more of what's going on. This sphere to the right is going to be our source of light. So we can increase or decrease the elevation of that. We can make him go closer or further. He can be on the inside even though it doesn't show the light. And we can rotate him around. So you can actually see here that the light is going around this cube. So if we could just increase our field or our dimensions a little bit, just so we could see, or decrease our dimensions, you can see how the lighting actually affects the entire cube. So if we look here, the lighting is actually consistent throughout the whole, and what it does is it actually shapes out the entire side. So what's actually going on there, if you would think that it would only light up a particular spot and not the entire section, lighting actually only is calculated at the vertices. So it's calculated all 4 of these vertices. Likewise, it's calculated all 4 of these vertices, and as you can see, the light is on this side of the cube, so that's why it's actually able to light that whole side there. If we go up a little bit, you can see it lights the entire all 4 vertices. So that's just something to think about. We'll get into that detail a little bit more of how you can make it seem like it's a lot better light source, I should say. So that's what we're going to take a look at, and we'll just really dig in mostly to this draw light function here, and then you can play around with a lot of the different functionality of. So we have an ambient, diffuse, specular, and position defined. Currently, diffuse is 100, specular is 0 emission and shininess, and ambient is 35. So what we're going to do is we're going to translate those into vectors by multiplying them by 0.01 for those 3. The position of the light is going to be the distance times the sine of light pH, the y coordinate, and then the distance times light pH cosine. That's just the position. We're going to be having a white cube here, white sphere. The sphere is going to have no lighting on itself, but it's going to be at position 0, 1, 2. It's going to be size of 0.0 or 0.1. And we have to normalize our vectors. Now, basically what that means is a normal should be a unit length of 1. So once again, review your linear algebra if you haven't. As an OpenGL, we always have to enable everything, so enable the lighting, as well as enabling glColorMaterial, which we'll cover more in detail later in another screencast. And then you need to enable that particular light. So this is going to be light number 0. OpenGL generally has the capabilities to do up to 8 lights. So those vectors that we had, we need to set those to the light for light 0. So lighting in OpenGL uses the Phong model. I can't really go into detail on that right now. I would just look it up online if you really want to know details. But it basically has ambient, diffuse, specular as the parts of the lighting. And once lighting is enabled, colors assigned by glColor aren't really used anymore. They're actually recalculated based off the lighting. So ambient is light that's been scattered by the environment, and so it's pretty you can't really control it. It just kind of goes everywhere. Diffuse light comes in from one direction, so it's brighter, and it glances off in that particular direction. And same with the specular. It's from a particular direction, bounce off on a preferred direction. Diffuse, the difference is it's brighter if it comes in squarely on the surface rather than glancing off. And finally, just position is the position of light. In our case, it's the same as the sphere. So really, the sphere has nothing to do with anything. So if we go back in here and we turn the light on and off, that's just, see, that's the regular colors. Whereas we have light. But if we go in here and let's say we comment out the sphere real quick, we make it, the lighting is still there. It's just the sphere lets us kind of have an idea of where it is. So it's kind of a convenience thing while we're working with it, but we don't really need it in our final product if we don't want it. So that's kind of what's going on here at a quick glance. As you can see, you can really play around with it. So I also set up a few more interactions that I showed you at the beginning. You can change the ambient all the way up, and it makes it look like, hey, why even have a light source, you know? So you'll probably want to have that down pretty low. I have it at 35 generally. Diffuse, you could play with that, lowering and raising that. Specular, you know, play around, and same with emissions. So you're playing with all the different things, and you can really see, you know, what the heck is going on here, and kind of really play with the lighting. We'll get into material more later, and you'll be able to really play with that too once we get into that. So this is just a starting for light. So you just kind of want to set it up, doing something like this. You'll want to make sure you have all of your normals, and just take a look at the code and have fun, and I will see you guys next time.